Hello.
Hello.
Hello, Mr. Ryan. Are you alright? Yeah. We have been talking about this water break problem. Okay. Water break problem. Yesterday we talked about a breakfast search. Yeah. Breakfast search. What's breakfast search?
Breakfast search is BFF.
Okay. So.
It's a type of thing, a way to search through a tree.
Okay. For example, this given this
Level by level.
Level by level. And how are
If
we
you ask.
implementing it?
Q.
Q, yeah, okay. Let's just quickly see how the breakfast search works. Okay, so for example, like 1, 2, 3, 4,
Whoa.
5, 6, 7. Okay. So first of all, we have a queue, double-ended queue, yeah, double-ended queue, and then at the beginning we put the 1 in, yeah, and then every time we take one item out of the queue, or we take everything out of the queue. Yeah? We push each kit. If we take one out, the kit is 2, 3, 4. We in-queue it one by one. Okay, so now that's the difference. Now we can take one, or we can take everything out. Right? If we take everything out, then we can make sure that all the nodes in the queue belongs to the same level. So if we take everything out, 2, 3, 4, the kit will be 5, 6, 8, 7. 5, 6, 7. We are given a list of words, and then also we are given a sentence, a string, and the task is to check if we be able to break the sentence, break the string using the words given. Okay, and we can use as many times the words as possible. Okay.
Yeah.
Does it make sense?
Yeah. Can you leave some letters out?
No. Oh, that's a very good question. We need to complete the whole string, right? So, for example, like A, B, C, D, E. If we have A, B, C, D, it's not possible to complete the string, right? Because A, we have B, we have C, we have C, D, but we don't have E, so we can't jump to the end. So how about A, B, C, D, and then if we have another B here, right? If A, B, C, D, B, B, E, and we have E as well. So then that's okay. A, B, C, D, B, B, yeah. We can use the B as many times as we want. Okay. Yesterday we talked about breakfast search. The day before yesterday we talked about breakfast search with the minimization and cache. Yeah? With the breakfast search, we still need to use the hash table to remember the path. We remember the split points we have visited. Right? Otherwise, the time complexity will be exponential because there might be some intermediate nodes that have been explored. That will be explored many times. So we don't want to do that. So today we're going to talk about the bottom-up dynamic problem.
And then top-down.
Now top-down is the recursion with minimization. Remember, we use the DFSI. DFSI. This is a function defined, and we put a cache. So DFSI, I is the index. Yeah, noting that at which position we are currently splitting, right? Okay. So it means that if we are at index I, if we can jump from index I to the end, that's basically what it means. And we put a cache just means that we were storing, we are remembering the intermediate result. For the bottom-up dynamic programming, it's the opposite way. So let's say if we have a DPI array, means that if we will be able to construct a substring from 0 index to I. Yeah, so basically, if we can construct a substring from 0 up to I, not including, that is what it means. For example, A, B, C, D, E. If DP 3, what does it mean? It means that 0, 1, 2, 3. If we can construct a string up to ABC, from start to ABC, if DP3 equals true, if there's a DE in the dictionary, if I'm telling you, we can jump from start to ABC here, right? We can construct a substring ABC, and if there's a DE in the string. So can you tell me if DP 0, 1, 2, 3, 4, 5, if DP is true or false? What I'm telling you, DP3 means that if we can jump to C, including C, this position, ABC, okay? You don't need to worry about how we are getting here, but the thing is that I'm telling you that we can jump to C at this position. Also, I'm telling you DE is in the dictionary. So can you tell me DP5? Can we jump to E here? DP3 means that we can jump to C position 0, 1, 2, 3, not including D. A, B, C. Okay, true. And I'm telling you, D, E is in the dictionary. So can you tell me if we are be able to jump to A, B, C, D, E here?
Yeah.
Yeah. Obviously. Look, we don't have to worry about how we get in here. I'm telling you, I know we can get to this point here. There's a DE in the dictionary, so obviously we can just connect these two pieces. Yeah, that's dynamic programming. Okay. So DPI means that if we will be able to jump to SI, right? We need to set it to true if we find what? If we find DPJ is true, and also S from J to I in W, we can update the DPI. Alright? Make sense?
Yeah.
So this is the opposite. For the DFSI, it means that if we can construct a substring from I to the end, right? And this is DPI, it means if we can construct a substring from the beginning to I, not including I, okay? Yeah, this is opposite. Basically, top down and bottom up are reverse direction, right? Remember Fibonacci number?
The first, 1, 0, 1, 1, 2, 3, 5.
Yeah, exactly.
8.
So Fn equals Fn minus 1 plus Fn minus 2, right? Yeah? If we using the recursion with the minimization from top to the bottom, that's top-down dynamic programming. But if we calculate F0, F1, and based on the first two values, we calculate F2, F3, right? F2, F3, exactly, that's bottom up, right? So this is the same. We are storing the DP values in an array instead of using the cache. Okay, that's the main difference between bottom-up dynamic programming and top-down dynamic programming. Okay, sometimes called recursion with minimization. Okay. So if you want to explain dynamic programming concept to mommy, what would you like to do?
It needs cache.
No, I mean, how would you explain this to someone who has not got the programming knowledge? What is dynamic programming?
Dynamic programming is minimization thing.
Yeah, remember the intermediate result, yeah? So for example, if I give you 5 chocolates, and like 10 minutes later I give you another chocolate, how many chocolate will you get? I give you 5 and then I give you 1 later, how many together?
6.
Yeah, easy. Why is that?
Because 5 plus 1 is...
Exactly, that's very simple. So you don't actually count how many in your hands, right? You're not counting, okay, I got 1, 2, 3, 4, 5, 6. Because you already know you have 5 in your hand. And 1 more coming. So how many together? 5 plus 1. Make sense?
Yeah.
That's the spirit of dynamic programming, storing the intermediate result. So we don't need to compute over and over again. Okay, we are reusing the intermediate results. Okay. Work break. Okay, let's coming back to this work break. The words. And now we got a string. First of all, we need to convert a list of words into a set. Why is it better if we converting a list of words into a set?
Because the lookup is quicker.
Lookup time is quicker. The hashtag. N will be the length of the words, the list. And then dp equals, at the beginning we set it to false, times n plus 1. Yeah. dp0, at the beginning we set it to true. When we talk about DPI, the I, this is the one index beyond previous one. So DP3 means that S1, S0, S1, S2, not including 3, okay? Yeah? So DP0, at the beginning we set it to true, yeah? Because if we're given nothing, we already make it, yeah? We'll already be able to split nothing, okay? And then for I in we iterate the split point, yeah, and then for j in range I, if dpj, okay, if we be able to go to dpj, right, and then also sj up to I is in w in the list. Right? So look, what we given this example before, ABC, we be able to get to ABC as DP3 here. But now I'm telling you, DE is in the dictionary, right? So D is in the dictionary. So that means that dpi we can set it to true, and then we can. Once we set it to true, we don't need to continue in the current loop. This is the spirit of the dynamic programming. I'm telling you that somehow we have constructed the substring ABC, right? Because DP3 is true. And then now I'm telling you that DE is in the dictionary. D is in the dictionary. So it means that we can construct a string, substring ABCDE, right? The last one we just have to check. Return DP n or dp minus 1, the last one, right? If we can construct the substring as n, right? If we can construct the substring as n, this is the same thing. Can we analyze the time complexity here? Look, one loop, one for, on, n times n squared. But here, substring on, so time complexity will be on times on times on is on cubed. The space complexity, we are allocating a space. So the space complexity is on. So the last question, what have you learned today so far? Come on.
Bottom up.
Bottom up.
Word play. Yeah.
What have you learned so far? Come on, can you tell me what have you learned about so far?
Word break.
Can you explain what's the
Dynamic
program?
programming. Yes. Bottom up.
Can you just say a little bit more, describe a little bit more, not just saying a few fancy words, okay? Please, come on.
Okay, we learned about
What's the problem and how are we solving it?
The problem is the same as yesterday.
What?
Yeah.
Come on. What? What's the problem?
You have a big chunky string which doesn't make sense,
And words.
and the words you've been given, and you have to break them up.
Yeah?
And see
You can
if
use-
they're in the words.
Yeah, you can use it more than twice, and no
And
other
you-
letters can be left out in the big string.
Okay, yeah, that's good.
And each letter in the string could only be used once.
The string in the list we can use as many times as we want. We don't need to use at most once. Yeah? There's no limit on how many times we can use it.
I mean like that one, Eric and
Okay, you mean the string? Yeah,
Yeah.
of course we'll be able to split
Yeah, I
the
said
sentence.
string, not words.
Okay. So how are we implementing this today?
We're using bottom-up dynamic programming.
Yeah, and how is that different from top-down and buffer search?
We're using cache.
Yeah, and we have to remember the thing.
Yeah. Okay. So what's
use-
the
Only the explanational.
exponential? Okay, the time complexity will be exponential.
Explanation.
So how many ways can we solve this problem? How many ways can we solve this problem?
2.
2?
No, 4.
Why is it 4? How many ways can we? What kind of argument have you learned in the past 3 days? Can we solve
Breadth
this?
search,
Buffer search
depth of search,
and what? And what's today?
Bottom-up.
Dynamic
Yeah.
programming. Okay.
so C.
Okay. That's it for today. Bye bye. And blue force over here. Yeah.
Bye
Bye-bye.
bye.